Bismillahirrahmanirrahim. Today we are going to solve Cambridge O-Level Physics Paper 2 Theory for the session of May-June 2024, and we have the subject code 5054 and the variant of the paper is 21. We have 1 hour 45 minutes for this paper, and this paper is carrying 18 marks, and the important instruction is written that we have to use the value of g, that is equal to 9.8 meter per second square. So we're going to start our question paper from question number 1. Okay, question number 1 is that a ball is released from the rest at point A and moves along a smooth track A, B, C, D, E as shown in the figure 1.1. The ball is shown at point A and it is as it passes point B. We can see A, B, C, D. From A to B we know that object will accelerate, and from B to C it moves, and C to D it will again accelerate, and D to E it will move with constant speed. So we have been given by the figure 1.2 show the distance time graph for the above situation from A to E. On figure 1.2, mark with the letter P and point where the ball accelerate, and with the letter Q where the ball has a constant speed, and we know that constant speed was at D and A. So we can see from the graph it has a constant gradient, so it is this way. It is showing at the constant speed Q. And now where the point, we have to plot point P where the ball accelerate. From A to B we know that object is accelerating, and we also know that at C to D the object is also accelerating. So we can say that between this point we can write P because initially it is accelerating, and we also know that from C to D it also accelerating. From the graph we can see it would be like that, from this portion to this portion that object is being accelerated. So P, even you write 1P, your will be considered correct, but it is necessary that you know that at both these points the object is accelerating. Moving to its second part, determining the speed of the ball at point X on figure 1.2. Show your working. It means we have to draw the gradient, and from the gradient we need to find the value of X. We can find the value of speed. Okay, so at X we need to draw the gradient. So first we need to draw the tangent, and from tangent we can measure the gradient point of this. Okay, this will be exactly this, or you can say this point is just tangent to it. Now you need to take 2 points, like I can take this point and this point where we can find the gradient. Okay, from this point has a coordinate of x-axis that is equal to 2, and y-axis has a coordinate of you can say it is 3.5 and 3.6. or from here you can see the x-axis has a point of 0.25 and y-axis has a point that is approximately equal to 0.2. So these are the 2 points that you need to take. Now you can calculate the gradient easily by subtracting those values. It would be like y2 minus y1, that is equal to 3.6 minus 0.2, then dividing it by 2 minus 0.25. It would be 3.4 over 1.75. So after dividing you can get the answer. The answer would be 1.94, and the examiner has been given the range that any answer between 1.9 till 2.4 would be considered correct. So this is how you will find the speed by drawing the tangent and calculating the gradient. Now for the B part, the speed of the ball at A, B, C, D are VA, VB, VC and VD respectively. Arrange these four speeds from slowest to fastest. Okay, we know that object is slowest at the starting point. So at VA the object would be slowest. So we will write over here VA. Now we know that at VC then object is again reaching the highest point, it would be slow down. So VC, and after that VD, and it would be fastest over VB. So this is how we will complete this. Work is done. Transfer energy between energy stored as the ball moves from A to B. Name the forces involved in the work done and describe the energy transfer. We know that work is done by the gravitation, force of attraction, and that is weight, and energy is transferred from gravitation potential energy to kinetic energy. So that was simple explanation. Moving to D part, the track at point B is in circular shape. On figure 1.1, draw to show the direction of the resultant force on the ball at point B. So it would be towards its center. So we're gonna show like that. On figure 1 point, it would be towards the center and it would move like that. So it will continue to move in the loop. Okay, moving to question number 2. Question number 2 is that a small aircraft takes off from the horizontal deck of a ship. Before taking off the aircraft, it is held in a place by a hold-back bar. When the hold-back bar is released, the aircraft is pulled along the deck by a steam-powered piston as shown in the figure. We can see from the figure, tank containing its a label diagram complete. The steam exerts a high pressure on the piston. Question number 8, part 1. Explain using ideas about particles how the steam creates a pressure on the piston. Okay, pressure is actually the force per unit area, or we can say force on unit area is known as pressure. When particle hits, actually pressure is when the particles collides with the wall of the container that it is kept on, or particles collide with each other. So you can write that when particles hit piston sides of the container, the pressure is exerted because each hit creates the force. So you can write the second part is that explain why the pressure on the piston increases as the temperature of the steam is increasing. When the temperature is increased, we know that particles have more kinetic energy. It means they will move more. When the particles will move more, they have more chances to collide with each other. So their chances of collision will increase. So that's why the pressure will also increase. So we can write that due to increase in temperature, particles have more kinetic energy. They will move faster. So the chances of collision also increases. That's why pressure is increased. Moving to its B part. B part is that when the pressure is high, the hold back bar is released. The steam pushes the piston along the pipe as shown in the figure 2.1. The piston has a cross section area that is given 0.3 meters square. The pressure of the steam in the tank is 2.1 into 10 to the power 6 Pascal. This is pressure, or the atmospheric pressure is 1 into 10 to the power 5. Determine the resultant force on the piston caused by the pressure difference. We know that pressure has a formula P is equal to F force per unit area, and we have to calculate the force, and force is equal to pressure into area. We have the force, we have the pressure, that is this, and we need to subtract them with each other. it would be like that, 1 into 10 to the power 5. And what is the area? That is equal to 0.3 meter square. So after solving it, you would get your answer, that is equal to 6 into 10 to the power 5 Newton. So our answer would be 6 into 10 to the power 5 Newton. Okay, moving to question number C. The force calculated in part B causes the aircraft to accelerate to a maximum speed of 28 meters per second from the rest. The mass of the aircraft is 3 into 10 to the power 4 kg. Calculate the momentum of the aircraft at maximum speed. So we know that formula for the momentum is P is equal to mv, and m is the mass that is given in the question, that is equal to 3 into 10 to the power 4, and we also know the velocity that is also given in the question, that is equal to 28. So we're going to multiply it by 28. After multiplying it, we would get our answer, that is equal to 8.4 into 10 to the power 5 kg meter per second. Moving to the next part, calculate the time taken for the aircraft to reach the maximum speed. Okay, this is a very interesting question in which we have to apply the formula for the force, but in a way, because we know that rate of change of momentum is also known as force. So you can write F is equal to m v minus u divided by t. This is the formula that is actually derived from the formula F is equal to ma, where a is rate of change of velocity. So you're going to apply it like that. We know that we have need to calculate the time. So the formula for the time would be t is equal to m v minus u divided by force. Now put those values. We know that the value of the mass is 3 into 10 to the power 4 from the previous part, and the value of the velocity is 28, then minus 0, and initial velocity is 0, and the force we just calculated in the previous part, that is equal to 8. That is equal to first part we have calculated 6 into 10 to the power 5. Okay, after solving this, we get the value, that is equal to 8.4 into 10 to the power 4 into 10 to the power 5, and 6 into 10 to the power 5. We're gonna cancel these, and after dividing 8.4 by 6, we get the answer, that is equal to 1.4 seconds. So our answer would be 1.4 seconds. Okay, moving to question number 3. Question number 3 is that a pan containing ice at minus 15 degrees Celsius, okay, placed on a glass heater as shown in the figure 3.1. Thermal conduction occurs in the metal from which the pan is made. By referring to the particle, describe the process of thermal conduction in a metal. Okay, we know that metal has free electrons available, so they move from hot area to cold area due to the diffusion, and when the vibration between the particles happen, these vibration passes the energy. So we can write that metal has free electron, they move from hot areas to cold area, the vibration between particles passes the energy, passes on energy. Part B. Figure 3.2 show how the temperature of the contents of the pan varies with the time. We can see that temperature start to increase, and from this temperature doesn't change. It means that this is the latent heat which is occupied to, which happens during the change in the state, and after the change in the state happens complete, then the temperature start to increase. Okay, I have the idea about the question. State the melting temperature of ice in Kelvin. We know that melting temperature is 0 degrees Celsius, but in Kelvin it is 273 Kelvin. Okay, explain why the temperature of the water is constant as the ice melt. Because during the change state, the energy we require wasted on removing removing the forces present between the particles. So we can write that latent heat is required, so energy supplied is being used to weaken the forces between particles, and kinetic energy of particles stays constant. Moving to its third part, the initial mass of ice is 1.5 kg and the initial temperature is minus 15 degrees Celsius. Okay, calculate the energy required to warm the ice to its melting temperature. So we know the formula is Q is equal to mc delta theta, where m is 1.5, where c is 2100, and where change in temperature is 0 minus 15. After calculating, we get the value that is equal to 47250 joules, or you can write that 47,000 joules. Moving to its fourth part. Fourth part is that all the energy transferred to the pan come from the heater. Okay. Using your answer in part 3 and figure 3.2, determine the heater used to warm the ice. Okay. So we need to find the temperature. We know that the formula is P is equal to energy over time, and we have the energy that is equal to 47,000. We just calculated in previous part. And what about the time? Okay, the time is 120, and how we get the time 120? It is actually 2 minutes, and we're gonna multiply 2 by 2 is from the graph, and 2 multiplied by 60 into seconds, so 120 seconds. So our answer is 120. We can see that here is 2. So from 2 minutes we change into 120 by multiplying it by 60. After dividing it, we get the answer that is equal to 391.7 watts, or you can write 390 watts. So both these answers would be considered correct. Okay, moving to part 5. The graph in figure 3.2 has a smaller gradient when the water is liquid than when it is solid. Suggests one reason. We can see that it has a smaller gradient and it has a greater. We know that water has a specific heat capacity compared to higher specific heat capacity compared to ice. So that's why water has the strong bond, and that's why the gradient is different, and gradient is smaller when it is in the liquid. So here the gradient is smaller and here the gradient is more. Okay, by mistaken I have told you wrong. In this phase the liquid is in the solid, so that's why it has more gradient compared to this, because water has a specific heat capacity compared to ice. Okay, moving to question number 4. Question number 4 is that ultrasound of frequency 30 kilohertz has a wavelength of 0.011 meter in the air. State what is meant by frequency. Frequency is the number of vibration in 1 second. Calculate the speed of ultrasound in the air. Show your working. We know that formula is P is equal to F lambda, where F is 30 kilohertz and 30 into 10 raised to power 3 to convert into the simple hertz, and the wavelength has the value of 0.011. After multiplying it, we get the answer that is equal to 330. So our answer would be 330 meter per second. Moving to this next part, state one use of ultrasound. We can say that we can use it for the cleaning. This for 1 mark, 1 use is enough, but you can write sonar, calculation of depth, parental testing, and other medical scanning. Okay, moving to next part. Next part is that sound wave are longitudinal wave. Water waves are transverse waves. Described by referring the movement of particles in the wave. The difference between a longitudinal wave and transverse wave, you may include the diagram. First, we have draw the longitudinal wave. Longitudinal wave, we know that they need medium to travel on. First, they have compression when the particles are closer, then refraction, then compression, then refraction, so on. And for transverse waves, they form crust and trough. Crust is from highest point from the mean position, trough is the lowest point from the mean position, and the distance between them is called amplitude. Between the mean and the crust, and between two consecutive crusts, it is called lambda, that is equal to wavelength. So now you can define longitudinal waves oscillation backward and forward in the direction of travel of wave. Transverse waves oscillation of right angle to the direction of the wave. So you can write that. Moving to its second part is state one source of wave that generates both longitudinal and transverse waves. We can write earthquake, or you can write lightning. Moving to its next part, C figure 4.1. 4.1 show the radio waves of long and short wavelength passing over the small hill. We can see that explain why the radio waves, explain why the radio waves in the diagram A reach the house, but the radio waves in the diagram B do not reach the house. You can see that here it reaches and here it doesn't. It is due to the diffraction. Long wavelengths bend around hill and short wavelengths do not bend. That's why the longer wavelengths are diffracted more and reaches the house. They have the longer wavelengths, so they will diffract more, and that's why they reaches the house. And they have the shorter wavelengths, they will diffract very little or less, that's why they didn't reach to the house. So this is, you can write in your answer to get 2 marks. So that was a question from the topic of wave. Moving to question number 5. Question number 5 is that figure 5.1 show the part of a circuit containing a 240 volt main supply connected to a lamp and two heaters of resistance 40 ohm and 60 ohm. You can see that that is 40 ohm and that is 60 ohm, and 240 volt AC main supply is there. Complete figure 5.1 by drawing the symbol for a fuse in the gap in the circuit. Okay, on figure I have drawn this. This is the symbol for the fuse. I am drawing again. This is the symbol of the fuse. Okay, there was a gap and I have put this on here. Moving to its B part, on figure 5.2, sketch a current voltage graph for filament. You need to draw Ohm's law concept. First it will be straight, and then after, when the temperature increases, the resistance also increase, so you need to bend like that. Okay, explain the shape of the current voltage graph in the shown in the figure. At higher current voltage, temperature and resistance increases, gradient of the graph decreases as the current voltage increases. So this was the simple explanation of Ohm law. Calculate the current at point P in the circuit shown in the figure 5.1. Okay, we know that the formula for the voltage is V is equal to IR, then I1 is equal to V by R. So it would be 240 over 40, you get it 6 ampere. Then I2 would be V over R2, and this would be equal to 240 over 60, and it would be 4 ampere. So the total current would be 6 plus 4, that is equal to 10 ampere. So our answer would be 10 ampere. Why we calculated for 2? Because first we calculated for this, these are the parallel, so the voltage remains same. So first we calculated for this and then this, and by adding we can get the current that is equal to 10 ampere. So that was an easy question. Moving to its D part, the current in the lamp is 1.5 amperes. Suggest a suitable fuse rating for the fuse. We know that the total current is value is 1, I is 6 plus 4, 10 we have already calculated, but the lamp has a 1.5 ampere, so its final value is 11.5 ampere. Okay, now fuse rating should be higher than 11.5 and it should be integer. Then we can say that it would be 12 or greater than 12, or you don't need to take 200 or 100, but you can go up to maximum limit of 20. Why you can't go that much high? That is the examiner asking the next question. Explain why a fuse rating much larger than in value is not suitable. Because if you use the value that is too much large, it will not melt the fuse, it will not shut down the circuit, because it will allow the current to pass, so it will not fuse. And the purpose of fuse is whenever the large amount of current passes, it breaks the circuit, so it melts and it breaks the circuit. But if its value is that much high, so it would not be suitable in their devices. Okay, so we can write that fuse rating much larger will not melt or shut down the circuit, and this will damage the lamp or any electrical appliance that is using in the operators. Okay, so you can write that. Moving to its next part is that explain why it is necessary to connect a fuse in the live wire rather than neutral wire or earth wire. You can write is when fuse is melted, supply of voltage is cut, so electrical appliances isolated. Okay, so that's why an appliance will remain safe. Moving to question number 6, that is from the topic of electromagnetic induction. Figure 6.1 show the structure of a simple electric motor. You can see magnet, commutator, carbon brushes, battery, coil, rotation. The current in the coil causes the coil to rotate. A student noticed that the coil turns in the direction to shown by the curved arrow in the figure 6.1. Part A. State what happens to the motor if a stronger magnet is used. If a stronger magnet is used, larger turning effect and will produce, and it will turn faster. On figure 6.1, mark and label the direction of the current in the coil and the direction of the magnetic field. So you can write that direction of the magnetic field would be from north to south. You can see now from north to south, it is the direction of the magnetic field, and for the direction of the current, you can like that. This is, you can draw anti-clockwise, and so these arrows would be showing those circuits. Explain why the coil turns. Okay, I have written a current carrying conductor is placed in a magnetic field. It experiences a force that is in the downward direction, and other side of the coil experiences a force that is upward. It means that right side will produce a downward direction and left side will produce the upward direction of the force. So it will make a couple that will cause the coil to rotate. So that was an explanation, simple explanation and very important explanation that is often asked by the examiner. Moving to its B part, the two vertical wires. Okay, two vertical wires carry equal currents in the opposite direction. They pass it right angle through a piece of card as shown in the figure. Current downwards and current upward, that is card. Figure 6.3 is a view of the card from the above. You can see that that is dot and that is cross, and we can see that over here the magnetic field is strong and over here the weak magnetic force. So you need to draw these circles, or you have been given by only the dots. Here from the dot I have drawn it anti-clockwise, and from the cross I have drawn it to the clockwise. Take it due to right hand rule. You can see and you can see. This is your right hand, this is your right hand, and thumb will point the north direction. Okay, on figure 6.3 sketch, I have indicate the direction of the magnetic field. On that I have the next part. The current in the two wires causes the wire to repel each other. Explain how the current in one wire causes a current on the other wire. The current in one wire causes magnetic field at the other wire, and wire on the left of a current experiences a force in the magnetic field. So these processes happen simultaneously and spontaneously. Okay, moving to Next part, question number 7. Question number 7 is that table 7 point show 4 different nuclei through thorium, protactinium, uranium 238, and the symbol is given. State what two nuclei have the same number of protons. You can see that uranium 235 and uranium 238 have the same number of protons because they have 92. They have, so you can write uranium 235 and uranium state which two nuclei have the same number of neutrons. Same number of neutrons have thorium 236 and uranium 238. 236 thorium and 238. After subtracting it, you would get that is equal to 146, and you also get here 146. So that's why they have the same number of neutrons. So you can write thorium 236 and uranium 238. Again, very simple. Moving to state, next state, which two nuclei have the same number of nucleons. Thorium 236 and protactinium 236 have the same number of nucleon. You can see 236 and 236. Okay, you can't see over here 236 and 236. So you can write thorium 236 and protactinium 236. Moving to B part, our teacher uses a Geiger-Müller tube and a counter to measure the background radiation in the laboratory. The counter records 20 counts per minute. A radioactive source is then placed in front of the tube and counter records 420 counts per minute. State what is meant by background. Background radiation is the radiation which is present in an environment naturally all the time. Okay, my second part is the measured count rate for 20 count per minute can be corrected for background radiation. Calculate the corrected count rate for that. We know that corrected count rate would be 420 minus 20. It would be 400. So our answer would be 400 count rate per minute. Moving to next part, the radioactive source has a half-life of 45 minutes. Describe the reading on the counter 90 minutes later. So it would be like that, 400 to 200 half-life, then it would be 100. Over here it would be 45 minutes, then it would be 90 minutes. So you will have 100, and now you can add that 20, 100 plus 20, it would be 120 count rate per minute. Moving to next part, suggest why your answer to third part is only estimate, because its value fluctuates. It doesn't constant due to the background radiation. Background radiation is not same at every place, so it's an estimate, you can say, or its value actually fluctuates. Moving to next part, next part is that figure 7.1 shows different uses of these different types of radiation. Draw a line on the figure 7.1. Okay, from each use of radiation to the type of radiation used, one line has been drawn for you. Each type of radiation can be used once, more than once, or not at all. So you can see that it is the use of radiation for the household, that are alpha particles, and for beta particles you can see measuring paper thickness, and for gamma radiation to irrigating food to kill bacteria, and sterilization of equipment. So that was question number 7 from the topic of radiation. Moving to question number 8. Question number 8 is that table 8.1 shows about 3 planets, Mercury, Venus and Earth. This is a very interesting question. Mercury, Venus and Earth. Time for the orbit of the Sun, distance from the Sun, average density and gravitational field strength is given. Part A. Figure 8.1, you can see figure 8.1 now, shows these planets in the alignment with the Sun. They rotate around the Sun in the direction shown. It means they are moving in clockwise direction. Mark and label on figure 8.1 the position of 3 planets in 110 days after the position shown in the figure. So you can write, for calculating the position of Mercury, 110 divided by 88, that is the distance from its Sun, and then multiplying it by 360, you get the 450. For completing in the circle, you can subtract it, 450 minus 360, it would be 90. So you can draw the position of the Mercury like that. Okay, you can see from Sun it is 2 centimeter from the Sun. So same here, you can draw 90 degree. We know that, right? 90 degree would be exactly like that. So you can write 2 centimeter, and over here it would be Mercury. Okay, for Venus, you know that 110 and its distance from the time for the orbit is 220, then it multiply by 360, you get the answer, that is 180. So Mercury, so Venus would be it's actually 4.2 centimeter away. So you need to draw 4.2 centimeter from here to show the position of the Venus, and over here it would be the position of the Venus. Now our planet Earth, 110 divided by 365 is the time, then multiply by 360, it would be 108 angle, and 108 angle would be relatively over here. So you can first note the distance, that is actually almost equal to 6 centimeters. So you can draw 108 from the D, and then from the D you can show that is equal to 108 degree. So you can, from here you can see that is 90 degree, and this is 108, and for 108 you have to draw 6 centimeter from here to show over Earth, that is over would be here. So you can draw over Earth like that. So this would be over Earth. You can draw the line or dotted line if you want to draw, but this diagram is enough to explain over movement. This was a very interesting and a new question that examiner has given in this paper. So you need to practice this concept to have a high chances of repetition or coming question like that. Moving to is B part. Each of 3 planets has a similar average density. Suggest why the gravitational field strength at the surface of the Mercury is much smaller than at the surface of the Venus. Because Mercury has a small mass. Next part is, an object has a weight that is 37 Newton on the surface of the Mercury. Calculate the weight on the surface of the Earth. Show your working. First we need to calculate the mass. W by gravity on the Mercury is 3.7. 37 by 3.7, it would be 10 kg. Then we have to multiply it, W is equal to mg, then 10 into 9.8 would be 98 Newton mass on weight on the Earth. How we have calculated? First we have calculated mass, because mass doesn't change wherever you go. In whichever planet you are traveling, your mass would remain same, but weight varies because it depends upon the gravity. So first you have calculated the mass from the weight and gravity on the Mercury. After calculating the mass, you multiply this mass to the value of the gravitational field strength on the Earth. You get the weight that is equal to 98 Newton. Moving to its next bar state, what is meant by moon? Moon is that natural large object that orbits our planet. So this is moon. Next part is the sun will eventually run out of hydrogen. Describe what happens to the sun when the hydrogen runs out. Okay, it becomes a red giant as it increases in the size and forms a planetary nebula and eventually becomes a white dwarf. So you can write this. It becomes a red giant as it increases in size and forms a planetary nebula and eventually becomes a white dwarf. So this is how we have completed our paper. If you do have any queries related to the paper, you can ask in the comment section. Do not forget to subscribe this channel and like this video. Thank you so much for the support and watching this video. Allah Hafiz.